Assalamu alaikum students. This is Dr. Sabina Qasim, your Research Methods and Skills course facilitator. Today, I'm going to teach you regression analysis for hypothesis testing. Now, what is regression analysis? Regression analysis is a powerful statistical method that allows you to examine the relationship between a dependent variable and one or more independent variable. Now, before running the multiple regression analysis, it is very important to note that there are certain assumptions that you need to keep in mind before running regression analysis. Number one is independent and dependent variable both should be quantitative in nature. Number two, there should be no outliers in the data set. Number three, normality should be there. Number four, there should be no autocorrelation. Number five, no multicollinearity. Number six, no heteroscedasticity. If you maintain all these things, then it will be good for you to run regression analysis. Okay, as you all know that we have already removed all the outliers and there is also normality in the data, so we can proceed for regression analysis. And we know that in the independent and dependent both variables are quantitative in nature, so we can proceed. Now let's start the analysis. Now you see, in regression analysis, we have to take, we don't have to take items while performing regression analysis. For that, we need to take the average of all those items. Like for example, there is a variable named PFB. It has items 1, 2, 3, 4. So before performing regression analysis, we need to take the average of it and make it one variable by transforming the variable into average. I'll teach you how to do that. Now, for this, you need to go on transform, compute variable. Okay. Now, over here, you have to type M, give the name to that variable. M for mean value, you can say. The variable name is PFB, parental financial behavior, PFB, right? You can see this variable. We have been using these variables in our previous tutorials. Now you see PFB 1, one item, 2, 3, 4, 5. Now in order to take the average, we are supposed to take all those items which we used while taking the reliability test. So if you remember, we skipped PFB3 at that time because by including this, the reliability was getting poor. So after deleting this item, the reliability, the Cronbach alpha value was improved, right? So in order to take the average of it, we take the simple method which we have studied in our primary classes. What we do is open the bracket first, take this value PBF1 at 2, skip third item, move on to 4, then 5, then bracket close upon 4. 1, 2, 3, 4 divided by the number of items upon 4, right? In this way, our MPFB variable will be created. You see, this variable is created. MPFB variable is created. Now, in order to save our time, I have already made these variables MPFT, MELC, all these variables. Now, with these variables, the aggregate values or the average values of these variables, we can use in regression analysis. Regression analysis does not use the items while performing the test. It takes the average value of the variable. Okay, so in the similar way, you have to conduct this test. You need to transform all the variables into average by performing the same test which I have just done of PFB. Okay, similarly, you should make the variable name MPFT for parental financial teaching. Take the average of all those variable items divided by the numbers that you have used. In this way, you will take the average, you will get the average value of that variable. Okay, now let's start the analysis. Now go on analyze, then regression, linear. Okay, now over here, the dependent variable is MYFB. You see, this is the dependent variable in the model. So I will place the average value, this one, mean value, over here in the dependent box, and PFT over here, this, and I'll take the selected one, these dependent variables in the dependent box. Okay, then what I'm going to put, then click on statistics, click on, put a check on estimates, model fit, collinearity diagnostics. Okay, Durbin-Watson. Now why Durbin-Watson? Durbin-Watson is used to check the multicollinearity and autocorrelation, probably the autocorrelation, and this collinearity diagnostic will help you to identify the multicollinearity. Does multicollinearity exist or not? So these tests will help to identify. Durbin-Watson is used to check the autocorrelation. Okay, then click continue. In this window, we have just put a check on estimates, model fitness, collinearity diagnostic, and Durbin-Watson. Click continue. Then click on plots. In plots, Z predicted will go on the X, which is, it says about the independent variable, and Z residual on Y, which is the dependent. Then you have to click on histogram, normal probability plots, both these things. Then click continue. Then click on save, predicted value unstandardized, predicted value and residual unstandardized. Then click continue. Then you just have to click OK. Right? Now I'll share the screen with you of output box so that you may have an idea. Now you see, these are the results. Model summary. Model summary. What it says, you will see these things, R square and adjusted R square. You read the value, you read adjusted R square because you have multiple independent variables and one dependent variable. In case if your model has only one dependent and one independent variable, there you will read R square. But since you have multiple independent variables, so you will read this adjusted R square. What it says, 2.213. That means 21%, 21.3% of your independent variable, a dependent variable is explained by your dependent variable. I'm again repeating, 21.3% of your dependent variable is explained by your independent variable. Because what your study said about, you are studying about the youth financial behavior. Youth financial behavior. Now the independent variables which you have used, let's, for example, you have used 3 or 4 independent variables. So it means 21.3% of your dependent variable is explained by those 3 independent variables. Okay, so it means there is some space for more independent variables. You can add more independent variables to improve your adjusted R square. Okay, now next is ANOVA table. Here you see F value, F statistics. With F statistic, it tells you about the model fitness. If its value is greater than 3.175, it means your model is fit, right? Now you see model, the value is 11.918. So it says that your model is fit. Then comes the main table that tells you about the significance or the hypothesis testing, whether your hypothesis of that particular independent variables are accepted or rejected. I've taken four independent variables. So these four independent variables have been used. That explains over here that 21.3% of your dependent variable is m, so this YFB. So your dependent variable, 21.3% of your YFB is explained by these four variables. Okay. Now, to test the hypothesis. Now, for instance, this is parental financial teaching has a significant impact on youth financial behavior. This is one hypothesis. Now, it says, is it uh, accepted or rejected? It is rejected because the significance value is 0.397. For hypothesis to be accepted, the significance value should be less than 0.05. So this is rejected. First one. Second is motivation, financial knowledge. Now, if we check this, now you see this is accepted because the value is less than 0.05. This is accepted. Third is peer influence. Peer influence has a significant impact on this youth financial behavior. This was the hypothesis. So it says that it is found to be insignificant because the significance value is greater than 0.05. So it is also insignificant. It means that it is also rejected. Out of three, two are rejected up till now. Fourth one is parental financial behavior has a significant impact on youth financial behavior. This was the hypothesis. Now, this is in fact accepted because the sig value is less than 0.05. It is very highly significant. All 0.000. That means it is highly significant. So this is accepted. So out of four hypotheses are one and two. Only two hypotheses are accepted. So this is how we check our hypothesis testing. I hope it is clear to you all. Now move on to this thing, collinearity statistic. Over here, we check the tolerance and VIF value. Tolerance and VIF stands for variance in inflation method. You know, this tolerance value should be if the value is closer to 1, if the value is closer to 1, it means there is no multicollinearity. And if the value is closer to 0, then it means there are serious issues of multicollinearity, because students often get confused when they find that their hypotheses are rejected. So if they try to manipulate the data, they try to use means which is not acceptable. But through collinearity diagnostic, they can easily try to understand if there is no multicollinearity problem or autocorrelation problem. They can continue their their findings. There is no problem that their data has some error. Okay, whatever the findings have come, you should report there. Don't change the findings. Don't get worried that your findings are incorrect, there is some problem. You, if there exists any problem, we can handle through here, through tolerance and VIF value. Now the tolerance value says if the value is great, it's closer to 1, then there is no multicollinearity issue. But if the value is closer to 0, then there is an issue of multicollinearity. Now other thing is for VIF value should be less than 10. If it is greater than 10 or closer to 10, there exists multicollinearity. So from these both the tables, we can have an idea that there is no issue of multicollinearity. Okay. Now, other thing is, yes, this Durbin-Watson. Durbin-Watson tells you about autocorrelation, right? Durbin-Watson value should lie between 1.5 to 2.5. If the value lies between this range, in this range of 1.5 to 2.5, there is no autocorrelation. Okay, so the value is 2.138. So there is no autocorrelation. So this is how you are supposed to do hypothesis testing. And now this regression analysis and hypothesis testing is clear to you all. and you are now even capable of reading your this coefficients table, with which you can have an idea whether your hypothesis is accepted or rejected. Always remember, if the value is less than 0.05, your hypotheses are accepted, and if it is greater than 0.05, it means your hypotheses are rejected. Hope this regression analysis tutorial is clear to you all. Thank you so much.